All right, hola, bienvenidos, welcome and welcome back. If you're new here, subscribe to the channel, and I want to answer a few comments. If you guys have been following me for a while, you understand how important to me my comments are, as far as like, any misinformation or, opinions or whatever it may be. I do take it serious. So every now and then we get comments, frowning upon something I've done in the video, stuff like that. First of all, I do want to say I am a licensed HVAC refrigeration contractor in the States, right? So a lot of the comments I get sometimes on certain practices are people from other countries, and I have no clue the difference between, the US and other countries, standards, code, all that kind of stuff. I don't know any of that. So I just show you what I do here where I'm at. And full disclaimer, electrical is my weakest point. I can't give you all the scientific electricity, back to front. I can't explain everything that happens with an electric current and the way electricity flows and all that kind of stuff. I just know what happens in my experience. So with electrical being my weakest point, I have a dad who was an electrician, and I would always call him for concerns, for how I'm wiring up something, how the electricity, might flow or the path of it. I always talk to him about it. Any safety concerns that I had, I talked to him about it again. So in no way, shape or form am I an expert on that part. I know refrigeration front to back. I do not know electricity that well. I do get shocked from time to time, and we're gonna test some things out in the comments that was said over and over and over again, but I've never actually experienced it. So we're gonna actually do it here live and test it. All right, and just before the video starts, full disclaimer, on my channel, in all of my videos, I just show real world scenarios, things that I do, and I just try to kind of enlighten people on, the stuff that we see. So whether it's safe or not, that's a whole other thing. I try to be as safe as I can. Our job, this industry, this trade is dangerous around every corner. I mean, I don't deny that. So going up ladders, being on rooftops, being in a hot attic, things like that, there's danger everywhere. We deal with high voltage a lot of the time. So like with any of that, you need to be careful, cautious. So, just be mindful out there. We're in the heat a lot of the time, and conditions are, rain, heat, the coldest of weather sometimes. And if you want to stay comfortable, don't deal with, sweaty feet, uncomfortable, nasty boots and socks, check out Camel City Mill. I'm just gonna, tell you real quick, give you a good tip, because some of you might not like this, where this video is headed, but the good tip for today is go check out the socks. They have these special blended merino wool socks, and they have these little air vents on them. It's witchcraft, because I work in Texas. We average sometimes like 115 degrees in the summer. I don't feel wet and nasty in my boots at the end of the day, and in the winter they're thick enough to where they're comfortable and warm. They also offer compression. If you go to camelcitymill.com, use the code reliablehvacr10, or just use the link down below, you can get a discount, 10-year warranty. If you ever put a hole in them, wear them out, if you mess them up, they'll replace them for free. They stand behind their product. I've been using them for basically a year now, and they're fantastic, best socks I've ever had. You get high quality, American made, 10-year warranty. All right, so here we are on my own unit. We do have the disconnect out, so there's no power right now. I've been working on it here and there. You can see we got a new capacitor, new contactor, things here and there. I'm currently trying to clean up the rest of it. Not installed by me, not every AC tech installs their own equipment. This has been here forever. It's an R22 system, but that's neither here nor there. So my setup, I do think, is one of the safer options out there. So we are disconnecting the wires from the contactor, making sure the thermostat is off, so we don't even get
any voltage on these and short anything out, you know, low voltage, 24 volts. Make sure nothing happens there. And then our high voltage is completely disconnected from the line side. We're gonna hook up to one leg because you get 208 single phase, and this is the same for anything. I mostly work on commercial 3-phase systems, but it's the same thing. You have 115 or 120 here, 120 on this leg. Together you get that 208 single phase here with your capacitor starting up your compressor. On the commercial stuff I see, it is 3 legs of 120 to give you that 208, 240 on a 3-phase system, right? No capacitor needed because you have those 3 legs. So like I said, I can't give you a breakdown of exactly how that works, but that's just the gist of it. So if we could disconnect our 2 lines here, like I said, 120, 120, we only need one to get 120, and then we need to ground the other side. I have this cable, car cable setup hooked up into here to keep that covered when it's spliced in. Just have a little cord that goes, and I chose to use a little extension if I need to plug in a few things. I won't run them at the same time, but like just having a few options there, and a switch, on and off switch. We are going to be testing what I would use the most for this, which is a recovery. They don't make a battery powered recovery machine yet, so this is something I still have to be plugging in. I've kind of switched over to battery powered vacuum pumps, but that's something different. So the first concern and the most common comment I get is you are connecting to the metal of the unit. We're grounding out on the case of the unit. So it is metal that gives you the ground. And the common comment I get is that now I am completing the circuit here and we're energizing this, and this is going to cause a bunch of shocks. If you touch this, you're going to electrify any metal from here all the way inside the house, things like that. I can't explain it, but that's the most common I get from electricians and experts that they claim that they are. No shade to you guys. I'm just explaining why I'm doing this video. So we're gonna test it like I was using it. So like I said, we're gonna take a leg, we're gonna ground out the other side, and then we're gonna double check our voltage. We're going to put this back in. So now this is live. When you do this, do not touch whatever wire is exposed. I have one exposed right there. So with one wire hooked up, which is the black, the red one grounded out, and we don't have anything plugged in right now, but we'll turn the switch on because right here, all right, we're gonna set it up so you can see it. There is I'm getting voltage, phantom something, but turn that on. Now we have 124. So it's live at the moment. Nothing's happening. I can touch this metal part too. I'm fine, right? So another comment was, you know, once you plug it in, so we're gonna get our recovery machine here. Once we plug it in, we're completing a circuit, right? Turn that on. I'm about to flip this around. So now this is on. We're gonna start it. So let me see if I can show this here. Like I'm gonna ground on the copper for the volts. So you get 24 there, right? I don't get it on any of the metal here, even if I go where I ground it out. Turn the unit on. I'll turn the unit on and check again really quick. I'm not getting a hint of voltage anywhere on the casing, any metal or anything like that. So just wanted to point that out. Okay, so I think this one is low on battery, but this one I just changed out the battery, and I was gonna do this non-contact test. So it's still on, still connected. See, I was like, oh man, maybe I got like some phantom voltage or like really low volts, you know, 10 volts, something like that. But just walking around, forgot one important detail. Power line. So honestly, I think I've had more issues with like a disconnect or breaker box still having like a, I don't know, like a wild leg or a bypassed leg and getting shocked that way versus ever energizing anything with a Widowmaker. Let me know in the comments though if you've ever, you know, used one of these and energized a case. I'm curious to see if it has happened, and maybe it's just never happened to me in almost 20 years and it's like a rare scenario. But with anything, like even when I mentioned the wild leg or the bypassed disconnects, breakers, a meter is your best friend. Now, whatever brand you want to use, do not trust non-contact voltage like I just showed, but always test, you know, with the leads. Check power to all the legs, check each leg to ground, and just, you know, verify that you're not touching something that's live. Oh, I did forget one test. What if I touch the case and touch something metal or grounded? There's not much like isolated metal I can touch, but I touched all the copper line. It was running. I touched the casing. Nothing happened. And I know I'm always sweaty, so I don't think I have to be wet for anything to happen. I'm trying to complete a circuit here and there's no circuit. I did test that with the meter and you saw that there was absolutely no voltage. Ooh, the wind picked up. All right, so I hope you guys got something out of it. I am in no way trying to be condescending about this. It's just, I've been doing this 18 years. And in that time, I've had to use a Widowmaker. Now they call it a Widowmaker for a reason. I just want, you know, my video that I had out there about it to be the safest option for somebody trying to do this, because even if I take that video down and like you said, or like people were saying, you know, don't show this to other techs, they're gonna hurt themselves, this and that. If I take my video down, there's gonna be 100 other videos of people doing it, hooking up a Widowmaker to a disconnect or a breaker box or whatever it is, trying to steal power, which to me would be unsafe. I tried to offer, you know, the safest possible option to do it. I showed it on residential, on commercial applications or light commercial. And I feel like, you know, still having to disconnect in place and then disconnecting the wires instead is a much safer option in my opinion. And that's the way I've been doing it. And like I said, never been shocked, never been hurt doing that, what I just showed you, running a vacuum pump, a recovery machine, whatever it may be. Now, I would greatly advise to get a battery powered pump. Milwaukee makes one. I think Uniweld makes one. Hvacr makes a few. And I know there's other ones that I'm probably forgetting. JB makes one. So there's a bunch of options there. Not so much for a recovery machine, which is where I still need to use something like that. Now, is it the safest? No. Do I want to do it? No. But if I'm up on the rooftop, especially if it's like a huge commercial job site, you cannot be running extension cords. There's no, it's not feasible, and not every unit has an outlet. And even if it does, 9 times out of 10 they don't work. They got wet, you know, with rain, or, you know, we have hurricane weather. They're out of commission, and it's not something
that I would know of before going. I get there, the outlet doesn't work on the unit, because there is going to be, if the installer was considerate, there will be an outlet on the RTU or on the roof somewhere. But most of the time, just like with water access, it's just not there. Like, there's no way around it. So that's my safest option, and I have to do it, like I said, for recovery machines. Unless you just don't want to recover or vacuum, like what else are you going to do, right? So I understand the concerns, but I've been doing it this long. I would advise you to find a different way. This is your last option to get power. There's, like I said, just no way around it. And I understand that me putting it out there maybe it doesn't look good, but my channel is all about realistic work scenarios and what I've done with my experience. I cannot talk about the science behind it. I can't explain electrical currents and all that. I can't get nerdy about that. My channel, I can only show you what I do in the field, and I've never been shocked doing that. I have been shocked before, and it is a horrible feeling, so please be careful. Like I said, you're gonna have some other, you might have a bare wire, this or that. Just do not touch or do not get close to it. Hook it up, run what you need to run, stand back, let it do its thing, and then move on to the next, you know, unplug it and disconnect the power. The way some people explain shocks, I don't know. I work around 208 three-phase power all the time. It is, now unless you go and grab it, and some guys can, you know, correct me on other ways this has happened, but unless you go and grab a live wire with a firm grip, yes, it's going to make your muscle, like, you know, tight and hold on to it and keep shocking you. For the most part, I get grazed, or I like quickly, you know, jump back when that happens, because getting shocked, in case, you know, anybody new is watching, it's not like a crackle or pop or anything like that that you might see like in the movies, or explosions or anything like that. It is, every time I've touched, and I've touched 120, like a single leg on a three-phase unit. I don't think I've ever been shocked on the 460 unit, but on a 208, 240, I've touched a leg before that was still live. I've, you know, made some mistakes in the past, and I still, to this day, I got shocked a couple months ago. What it feels like is, as soon as you touch it, it is like the most vicious vibration through your body. It's not a, like I said, a snap, explosion, crack, whatever you want to call it. Like, it is a vibration, you know, all throughout your body, and it is the ugliest feeling to me. So I try to take precaution to avoid that. You still get a little tingle on like 24 volts with low voltage. In our industry, right, you deal with low voltage at 24 and high at 120, 208, you know, that kind of voltage. So I am a little scared of electricity, and I feel safe doing that. I've actually gotten worse, or it hurts more when I get static shocked. So like, my couch gives me static electricity sometimes. I go to the fridge to grab something and I get a big pop, and it, you know, that little shock, and that hurts more than the 208. The 208 just feels ugly. Like I said, it vibrates you, and you kind of get this little, to me, when it happens in the morning, it's like a little wake-up call. But anyway, I don't want to get too far into that. I'll leave this video as a follow-up to the other one. I'll leave it in the comments of that video in case they see that video. They can come and see me testing it live. And that's going to be the same test if I do it on any equipment, because when I run my vacuum or recovery machine, I'm still working on the unit. I'm still disconnecting, cutting, doing something. And I have all my tools on the unit, like on an RTU commercial appliance. I've never been shocked. I've asked around. Nobody else has been shocked doing that. Yet I get a lot of comments that I'm energizing all this other stuff. So it's beyond me. Like I said, if you're an expert, please explain to me why I didn't get shocked down in the comments. And then if there's anything else I can test, I will. Like I said, I listen to my comments. I want my channel to be informative, educational, somewhat safe, because let's be honest, this HVAC trade, you're on rooftops, you're on ladders, you can be in a sketchy place and still have to do your job. It's not always safe. but it's the safest that I can be. The wind is about to take out my camera. I'm ranting on too long. Hope you guys enjoyed the video. Remember to like, comment, subscribe, all that good stuff. Like I said, give me some feedback in the comments now. I kind of tested one of the theories in the comments that I got a lot of. So I don't know. Correct me now. See you guys.